In this video, I'm going to talk about why you might want to use an interface in your programs. So let's take a look at this hierarchy and you'll see how it's useful. I have a MyDevice superclass with two subclasses, and the method I'm going to focus in on is this connect to Bluetooth method. So I'm going to say all my devices can connect to Bluetooth. Okay. In my subclasses, I have concrete methods, in other words, methods with actual code in them. It's pretty simple, just a print statement. And my pod has it as well. Okay. Separately, in this other hierarchy, my car, because it's Bluetoothable, can also connect to Bluetooth. So there's a common method there. So if I close it up and take a look at a driver, I can see here I'm creating new a pod and a phone and a car. Okay, I can actually group the pod and phone together in an array list of my device because they are of the my device superclass. So that works. And because I can group them together, I can add them to the array list and I can process them together polymorphically in one single for each loop. The car, though, is kind of an outlier. It doesn't fit. A car is not a my device. It's a vehicle. It belongs to a different superclass. And in Java, as in many languages, you can't inherit from two separate superclasses. That's called multiple inheritance. You have to be essentially one thing or essentially another. You can't be two things. So because of that fact, I have to have a separate line of code. And this is a real simple example, but you can imagine I might have to have a separate array list for vehicles and a separate for each loop. And then if I were the third thing, it could get kind of complicated. I'd like to have one for each loop that handles them all. So let's see how we can do that. So if I close this, let me just run it first, so you can see. If I run it, these are processed in the for each loop, and this one's done separately. So again, I'd like to have one for each loop take care of everything. So here's the solution, an interface. I'm going to say new class, let's create an interface, and I'm going to say it's called Connectable. And you can actually click on interface. I usually click on class because we're going to delete everything in the code anyway. There's nothing special about any of these, it's just what I type in. If I click OK, what makes it special is I'm going to say, I'm going to highlight everything and delete it. Public, not class, but interface. That's the special word. Connectable 1, 2, 3, and interface. It's not a class. It is a collection of abstract methods. An interface is simply a collection of one or more abstract methods. That's all it is. Okay, you'll see how this comes in handy with the driver in a second. So I'm going to say public string connect to Bluetooth semicolon. This is 100% abstract. You actually, I think I use void, but to make sure it's abstract, I'll put that there. Okay, so it's 100% abstract. I'm going to close it, and then I'm going to tell my device and my vehicle, you are connectable. So I'm going to say implements connectable. In inheritance, we use the word extends. With interfaces, we use implements. It does those things. And then vehicle also implements connectable. Close. And you'll see a couple things happen here. If I compile, the word interface is put there simply because I put the word interface. So there's nothing about the that dialog box you saw earlier. And you'll see now there are dotted arrows pointing up to connectable. So they're not this is not a class, so I don't have inheritance. I'm just saying they will do connectable things. In other words, they will do Bluetoothable things. So this solves our problem. I can now go back into the driver and say, you know what? I'm not going to create an array list of my device. I'll create an array list of connectable things. It's not a class, it's an interface, but I can still do this. Connectable. And now, because my car is a vehicle but does connectable things, and my pod does connectable things, and my phone does connectable things, specifically connect to Bluetooth, because they all do that thing, it's a common element or common method, I can say inventory dot add car, and then get rid of this line here, I'm not dealing with my devices, I'm dealing with connectable things. And there's the line of code that I don't need to change. It should work, because if it's truly connectable, it has this method, so I'm guaranteed that that works. If I compile it, if I type everything right in there, close it, and run it, it works. So this solves the problem of grouping things together. I've created a new thing called an interface, which is a collection of abstract methods solely. And I'm saying, okay, if everything in this hierarchy agrees to do connectable things, in other words, connect to Bluetooth, then I'm guaranteed that this for loop will work. It's like saying if I have an action, the subclasses will have that action. Now, here I made vehicle implement the connectable. I don't actually need to do that here. I could actually say and get rid of this. Let me comment this out. Let's say I could actually just have my car do it. I could say implements vehicle, and I can make the relationship there. So it can, my car can extend the vehicle class but do connectable things. So I have a choice, depending on what my program does and how I want to organize it, what implements connectables. So again, this right here allows me to create array list of connectable things, and I can include seemingly different objects, even more so than before, seemingly different objects, and run through their methods polymorphically. So that's very powerful because it cleans up my program and gives me a way to group things more conceptually.